Hello everybody and welcome to another video here at TD Channel. Today we're gonna keep doing a little bit more work in going over the basis of using the RenderMan interface language or RenderMan shading language. And today we're going to concentrate on how you go about doing simple texture mapping. As you all might know, texture mapping is one of the simplest ways to try to get the look that you want for an object when you are applying materials. So right now what we're going to do is we're going to go over the process of writing a shader that can take textures as input parameters, and we're also going to look into a little bit of manipulation of these shaders. So let's go into a little bit of the theory behind it. Okay, so the first thing that I want to convey is that you're probably, if you have been using CG for a while, you are probably familiar with what UVs are. If not, we'll go over them a little bit. But basically, what we're trying to make sure here is that we understand that what is usually talked to in most applications as UV coordinates, in RenderMan you usually refer to them as ST coordinates, even though the ST coordinates refer more to the parametric coordinates of your surface. It's usually how people refer to them in RenderMan lingo per se. So just get used to this. While I start using the phrase ST, what I'm really referring to is UV coordinates. Now, as you might know, UV texturing is basically the process of transforming a point in 3D into a 2D coordinate. And the reason why you do that is because now you want to have, for every point, you want to have a 3D and a 2D position. And the reason why you need a 2D position is because your textures are two-dimensional. They only have width and height. So you have to find a way to map your three-dimensional point into a place somewhere inside this square right here. So once you're able to do that conversion, like as you can see on the previous image, here is a mesh that has been unwrapped, and even though this used to have 3D data, now it is a flat 2D object, and now all these points know where they can find the required data inside the texture map that you're looking at. So how are textures applied in RenderMan shading language? Well, in RSL you would use the texture function, and here is a little bit of documentation on it. Basically, what you're going to do first, you're going to type the type of data that you're trying to read. So if you're trying to read a float, like for example if you have a grayscale map, you would usually prepend it with the word float. Then you have the keyword texture, which is the function that's going to do the lookup. Then after that you're going to have a string, which is going to be usually the path to where your texture lives. After the string, you can have between square brackets, you can have the channel where you want the render to start looking, doing the lookup, and we'll expand into this a little bit in a second. Then after that, you're going to have the texture coordinates, which can be one of different, you can specify texture coordinate in different ways. And then at the end you have parameter lists, which are basically the parameters that the texture can take. The second signature here is pretty much exactly the same, except that now you are doing a color lookup. Now, as I talked about channels, basically the way this works is that if you're trying to do a color lookup and you give it a string name and you don't give it the channel, basically what most RenderMan renderers are going to do is they're going to look up the first available channel in your texture. So usually that's the red channel. And then, because you're trying to look for color, it's going to look for the other two additional components it's going to need for the color. So it's going to look for channel 0, which is R for red. Then it's going to look for channel 1, which is green. And then finally it's going to look for channel 2, which is blue. And that's going to allow you to do this, to do your color lookup. On the other hand, if you're doing a float lookup, chances are, because it knows that it only needs to do a float lookup, so it only is going to need one channel. So if you give it something like a texture that is a color texture, right? So it has 3 channels, and you give that to a float lookup, what it's going to do is going to look up the red channel and it's going to ignore the other ones, because it can only handle a float, so it's going to look for one channel. So if you're trying to, let's say that to be a little bit more efficient, you're saving into color images, into a color image, you're saving different channels for different modulations. Let's say you're trying to use the red channel to control the diffuse intensity, the green channel to control the specular, and the blue channel to control reflectivity. Or what you would have to do is give it here where this channel is, you would have to give it the exact channel you want. And remember, channels are arrays which always start in 0. So if you wanted to get the red channel, like I said, for diffusity, you would do float texture, your string name, square brackets, and then you would give it a number 0 there because you're reading the first channel. So let's go ahead and go through a process of writing a simple texture shader. I usually like to go ahead and start coding so you guys get a little bit of a better feeling of what we're doing. So right now I'm in this location right here, and this folder, if I hit ls, you're gonna see is empty. So the first thing I'm going to do is I'm going to create my development environment. So I'm going to go ahead and do make directory, and I'm going to create a source folder and a binaries folder, which is where I'm going to do all my releases. So if you do list now, you'll see that I have both of those. Now, you probably saw in the previous RenderMan video that I started using makefiles so that I could control my compilation a little bit better. So I'm going to go ahead and do that. So I'm going to use my favorite text editor, which is Vim. I'm just going to type vim makefile. Right? And you can do this in any text editor. Just name the file makefile with no extension. Alright, so this file is going to be very simple, and I'm just going to do a couple of, I'm just going to type a little bit here. First, we're going to create a variable called buildir, which is going to be our build directory, and we're going to give it the value of bin. Next, we're going to do source directory, and we're going to give this a value of source. Then next, we're going to tell the makefile how to find the source files that we need to build. So we're going to do SL sources, and we're going to use, and you know, we're going to have another video explaining makefiles more in details. Right now you can just follow along and type as I do. So we're going to do wildcard, which is a special function that you need here, and we're going to do $source directory, and then slash and SL file, because all our source files are going to have the extension SL. So basically what you're doing is, I want to find in the source directory all of the files that end with SL, and that's going to store it in a variable called SL sources. Now we're going to do SLO targets, and we're going to basically do a replacement on the previous one, and you do that this way, SL sources, and then you're going to go over here and just do a :.sl, and we're going to replace that for .slo, right? So one thing I'm forgetting is actually you need to put a colon here because you're processing things beforehand. Now we're going to go ahead and we're going to make one more replacement inside the SLO target. So we're going to do SLO targets, and then we're going to tell it that we want to do we're going to do a substitution, and we're going to do source bin, and then we're going to tell it what we want to work on. So SLO targets. So what this does is basically is going to go through all the different elements that it finds in SLO targets, and wherever it finds the word source, it's going to replace it for the word bin. So this is going to give us our targets. Now down here we're going to go ahead and tell it what's our all build, like if you want to build everything, and we're just going to tell it that is SLO targets. And then farther down here we're going to do bin .slo, and this is going to be source SL. And then here we're going to type shader, which is the command for RenderMan compiling. For this tutorial we're using actual Pixar's RenderMan. So we're going to go and do shaders -C, which is a flag that allows you to preserve some metadata that is going to be useful for user interface creation, and we'll see that a little bit later on. And then we're going to tell it that the output, it's going to be this sign, which represents this sign represents whatever this wildcard here expands to. So actually, let me go over here. I think we're missing a slash. So this is going to expand to whatever this expands to. So that's this variable for this particular rule. And then we're going to tell it what the input is. So the input is this. So basically here we have a rule. Let me go ahead and write this. And I think actually I have to do set. So I have to type in this, which is basically you're telling it that you don't want to use spaces instead of tab, which is I usually have my editor set to that because I do a lot of Python coding. But for makefiles, you need to use tabs. So I'm going to do this, and then I'm going to go ahead and retab this. And we should see this change colors. So now that it changed colors into red, now we know that it's actually a proper rule. Like I said, we'll have another video where this is gonna we're gonna go over this, and it's probably gonna make a lot more sense. But this is pretty much all we need right now. So this file is already saved, and now we're gonna go ahead and move into our texture that we're trying to write, our shader that we're trying to write. So I'm going to do write source. And then in here, we're going to write a file called simple texture, SL. And actually, I just wrote this file as simple texture SL. I made a little mistake here. Let's go ahead and do edit source simple texture.sl. I'm going to delete all this from here because that was wrong. So what we're going to do is I want to test my makefile really quick. So I'm going to do just a simple shader here. So we're going to do surface simple texture. And we're just going to basically do a hello world shader. We already went through this in a previous video, so I'm not going to take the time to go over it again. So here's going to be OI times CS. Alright, so now that being done, we can probably exit out of this, and what our tree looks like right now is we have a make file, we have our binary folder, and we have our source folder. So now I should be able to type make, and it's going to build the shader, and it's going to move it from the source file to the binary file. So let's see what happens. Okay, it seemed to have worked. It called our command, it found it found the source file over here, and it created this output file right here. So our make file seems to be working, and one of the things that you can check is you can do ls bin to see what's inside the binary, and you see that that's where it went, the result compiled shader. And now if you run make again, it's going to tell you that there's nothing to be done, because one of the cool things about a make file is that it compares your target against your sources. And if the target is older than the source, then it knows that it shouldn't need to build anything because it's already built. So we're going to go ahead and do edit source simple texture. And I use this E, which is basically a simple alias that I use, but you can do Vim. And we're going to go back into a shader. So the first thing we're going to do is create our shader parameter. So I'm going to go in here and organize this a little bit. I like try to keep a clean house. Actually, this one should probably be over here. Okay, so that being done, we're going to start defining our parameters for a shader. So the first one we're going to do is we're going to do diffuse multiplier. We're going to give it a value of 0.8. Next, we're going to do a color, surface color. And this we're going to give it a value of 0.5. And you can initialize colors with a single value like this. And basically what it's going to do is copy it to the other positions. So RG and B are going to be 0.5. Then we're going to do string map. And we're going to initialize it as an empty string. And this is going to be the string that points to our texture map. Then we're going to do something such as let's see, actually, let's go ahead and leave it as is right now so that we'll probably build this progressively as we need to add more features. So we're going to go in here now, And we're going to create some local variables. The first one we're going to need is a normalized normal. So we're going to do normal nn equals, right? So now we have normalized the normal of the surface, and we've stored it in nn. Now we're going to create a couple of color variables. We're going to create one that's called color sc for surface color, and we're going to initialize that to surface color, which is coming from our parameters. Then we're going to create another one, and this is going to be LC, which stands for layer color, and we're going to initialize that to black. So we have that. So now we're ready to do our texture lookup. So what we're going to do is we're going to go ahead and first we're going to make sure that if the map has been provided, then we use it, because if someone doesn't provide a texture map, there's no reason for us to go into that code. And that is something that you constantly have to think about when you're developing shaders, is make sure you don't execute code that you don't need to. So we're going to do something like if map is not equals to empty string, which is the default value over here, then we're going to go into code block. And in here, what we're going to do is we're going to do something very simple to start. We're going to do surface color is equal to color texture, and here's where you're seeing the call that I did before, and we're going to give it the value of map, and that's all we're going to use. So down here we're going to replace this CS, and we're going to do SC, which is the value that we just assigned over here, and we're going to multiply this by the diffuse using that normal and times the diffuse coefficient. So right now we have a very simple texture that basically, if the texture is provided, is going to override the surface color and is going to give you a Lambert shader with the texture applied on the default surface, the default texture coordinates of the object. What are those? We'll go over them very soon. So right now I'm going to go ahead and save this, and I'm going to go ahead and run make. One of the cool things about Vim is that you can just type colon and then exclamation point, and then type the command that you want to run on the shell behind. So I can just do make, and it's going to run it. And I believe that compiled already, quite fast. So let's see how we can use this shader. And for this tutorial, like I said, I'm using RenderMan products, Pixar RenderMan products, and what I have here is I have a Maya session that has RenderMan Studio loaded into it. So in RenderMan Studio, the way that you assign, there's several ways you can assign shaders to your geometry. We're going to use this method over here, which basically on the RenderMan Studio tab, you're going to have a little button that says assign RenderMan shader to selected objects. So the object is selected, I'm going to click on it, and it's going to create this little node here in the attribute editor. So at this point it has a default surface, and I should be able to go ahead and click render, and there it goes. It kind of went through. Nothing great to see there. Let's analyze what this object has over here. So if we go into the UV texture editor, we see this object doesn't really have a UV set. This is the default UV set, and it's mapped 0 to 1, basically a perfect projection. Most procedural objects like a grid or a sphere, a lot of them have built-in ways of automatically texture mapping themselves. So this is the texture that we have at the moment. So we're going to go ahead and load our shader here, and basically what you do is you click on this button, and you're going to go find the shader that you just compiled. So I'm going to go here into texture mapping binaries and find the simple texture.slo that I did earlier. So here you have the 3 parameters that we created for a shader. So that's one of the cool things about RenderMan Studio. It puts a GUI for it for you. So you can see we had a float KD, a surface color, and a map. And if we go back, that's what we have over here: KD, surface color, and a map. Now the map at the moment, it would be cool to have a little icon like this one so that you can go find stuff. Now we don't have that at the moment, and we'll probably go through that later. So let's go ahead and test, make sure that this shader is properly assigned. We're going to go ahead and make this, let's make it a magenta tone, and go ahead and click render. and we have our magenta shader. Like I said, this scene is very simple. All I have is a little light over here, and this light has a area light from RenderMan Studio assigned to it, and we're able to render. So that being done, let's go ahead and try to apply the texture to this map. So if I go over here, I'm going to go ahead and let's exit out of this, and let me do this, get my current working directory, copy this string, and then open a new shell and navigate to that location. Let's make this a little bit bigger. So I'm going to go to this location, which is where I prepared the shader, and here if I go into images, I have all these textures over here. So if I use something like open tdctexture.tiff, it should bring up this little guy right here. And right now you can see where the alpha mask is. You know, this checkered pattern means that there's an alpha. So it's basically a TD channel logo. It's stored as a TIFF texture. The reason why you need it as a TIFF texture is because RenderMan will only take textures that have been converted to the texture to the RenderMan texture format, and this is a format that is extremely efficient for rendering. Basically, you can load hundreds and hundreds of huge amounts of textures that have a lot of data. You know, 4K textures, and you can have hundreds of them. And let's say that your object is really close to the screen, then RenderMan will look up a high quality version of the texture. But if let's say your object is far away from the screen, then what RenderMan is going to do is going to load a lower quality or a lower resolution version of your texture. And the way it does this is inside the texture format, you're going to have, let's say you give it a 512 by 512 texture. Then inside the texture format is going to store a 512, a 256, a 128, a 64, a 32. Basically every power of 2 is going to store it in the texture in a MIP map tree. And like I said, what this allows the renderer to do is determine, based on how big your object is on the screen, is going to determine which of these textures it uses. So it's extremely aggressive at being efficient, and you know, that's what we get out of it. So we have to convert our textures to that format. So I have this TIFF texture, and the way you convert it, there's a command called txmake, and if you type that, it will, and if RenderMan is properly configured, it will give you all this information. In previous tutorials, I was using 3D Light, and I believe 3D Light's it's make tx or tdl make. Yeah, tdl make. That's the one that 3D Light uses, and as you can see, it uses very similar calls. So since we're using RenderMan, we're going to use txmake, and then we're going to tell it that we want to use tdctexture.tiff, and that we want to output tdctexture.tx, right? So that went ahead and gave us our tdctexture.tx. Now there's another command in PRMan that ships with PRMan that's called txinfo, and to make sure that it has been properly created, you can run this on the tx file, and it's going to give you this breakdown of what's going on with the texture. So it's going to tell you, okay, this texture has 4 channels, and it has from resolutions all the way down from 2 by 2 all the way up to 512 by 512. Then it gives you some other information, then S mode and T mode, and we'll go over this in another tutorial, but basically it relates on how it's going to handle the texture when it goes out of the texture area, and like I said, we'll cover that. So we know we have a proper texture. Now we should be able to use this, so I'm going to go ahead and copy this path, and I'm going to go over here. I'm going to place it right there, and we know the texture name is tdctexture.tx, and you can see as soon as we hit enter, the little widget changes here, so that means it's finding it. And if I click render now, there you go, we have officially mapped our grid. Now as you saw in the shader, if I show over here and I do again film source simple texture, like as I said, if the map is found, we're doing a full-on override. And I'm going to show you very soon how to use the alpha channel on this. But as we look back here, we see that the UV coordinates are flipped from the way we would want them. And this is something that happens quite commonly. Basically, it has to do with the handiness of the application that you're using and how it exports stuff into the RIB file format. So Maya is sending the STs in a way that's probably flipped from what the TIFF is stored. Or the texture is stored. So we're going to have to find a way to flip it. And this is quite easy to implement. So let's go ahead and implement this. Let's go over here and add a couple of parameters. We're going to do uniform float flip S and give it a value of 0. And then uniform float flip T and give it a value of 0. So now this is going to control when we want to flip things. And now inside of map, what we're going to do is we're going to create a couple of new variables. We're going to create a variable called SS, and we're going to initialize it to this value. We're going to say flip S equals to 1. Basically, we're asking it if flip S is equal to 1, then we want to use 1 minus S, which is, like I said, S is U. If not, then use S. And we're going to do the same with TT. If flip T is equals to 1, then use 1 minus T. Otherwise, use T. And this is actually a colon. So, as I said earlier, S is U and T is V based on on the standard built-in texture coordinates of an object, if it has it. Not always, it doesn't always have it. Now you see our call here for texture. We just didn't give it anything else other than the texture file. That means that it's going to use the default ST coordinates that it finds in the object if it finds them. And most objects have something. It's just that a lot of times they might not be useful at all. In our case, the grid, because it's a square, it's very easy to map this into a 2D texture, so it pretty much gives you the right thing. But now what we want to do is, we're telling that instead of using the standard ST, which would usually look like this, we're going to tell it use the one that we created, which has our special manipulation, which just allows us to flip things around. So that being done, we're going to go ahead and make this and compile. It compiled. So now if I go over here and I do a reload, it should give us a couple of other switches here. So if I tell it to flip it on S and I give it a render, there you go. We have flipped it on the S direction, which is the U direction, and now the texture looks properly. Let's go ahead and test the other one, and if we do this, we should see the texture flip the other way also. And there you go. So you just saw how you would do texture flipping, which is usually just do a 1 minus the texture coordinate, like we have done over here. Like I said, this line right here, what it does is first it compares flip S against the value of 1, and then what it does is the first spot here is what is returned if this condition is true, and this over here will be returned if this condition is false. So if flip S is equal to 1, then we do 1 minus S. If not, we use S. So that being done, let's go ahead and do the last bit of changes to our texture. And basically, we want to be able to preserve the surface color. Basically, we want to be able to apply our texture, which has an alpha channel, as you saw on that TIFF. We want to be able to apply it as a decal on top of this color. So right now, it's completely overriding, and that's probably not a good behavior for users. So we're going to go ahead and add one more parameter here, and we're going to do uniform float use alpha, and then we're going to give it a value of 0 by default. Actually, let's go ahead and switch that to 1, because basically if the texture has an alpha, we don't want to have to do any extra steps. You should probably use it because that's what you intended. That's why you put the alpha there. So what we're going to do now is, instead of always writing directly to the surface color, we're going to store this on the layer color. So we're going to store the value of this into the layer color because we don't quite know how we're going to use it yet. So that being stored, we're going to go over here and we're going to do if use alpha is equals to 1, and then we're going to go ahead and close this. So we have our code block. And then in here, what we're going to do is first we're going to gather some information about the texture. And for this, there is a call called texture info. So you can do texture info, and then you're going to give it the map, and then you tell it, okay, what do you want to look up? And I'm going to say, okay, I want to look up channels, which is one of the things that you can look up from texture info. And I'm going to store the value of channels into a variable called numChannels. And the way that this works is that usually what it's going to do is it's going to run this function and it's going to try to find the value of channels. And instead of returning it over here, like for example this is doing, where you can do an assignment, what it's going to do is it's going to store the value in whatever you pass over here. And it's going to return 0 or 1 if it found the texture channels or not. So for this to work, what you have to do is you have to make sure that this matches the lookup of this channel. And if I show you guys the documentation on this, let's go ahead and find it. I think I have it over here. Let's go ahead and let's do RSL and do a texture lookup. So there's our documentation for texture. So where you have that, actually we wanted to look texture info, not texture. So let's go at texture info. So it's going to tell you some information, and basically it tells you you have to give it the texture name, the query, and a variable where you're going to store the output of that query. So if you look at this table, it tells you these are all the different things that I can look into a texture. Like it can look up the resolution, the type, the width, height, a whole bunch of different things. But the one we're interested in right now is channels. And it tells me that channels, the return type is a uniform float. So that means that we're going to have to create a variable that is set as a uniform float. So we're going to do uniform float numChannels, or we're going to initialize this to 0, and then we're going to store this over here. So now that we know, by this point we already know we have stored in numChannels how many channels the texture has. So now we're going to do something like if numChannels is equal to 4, that means the texture has an alpha. So we're going to go ahead and use that alpha to do something like surface color is going to be the result of a mix between the surface color, and that's going to be at the bottom. And on top we're going to put the layer color, which is the texture lookup that we did over here. And then for the alpha we're going to do a float texture, and we're going to tell it that we want to use map. And here's where we're going to use the channel that I was talking about. We're going to tell it that we want to use the 4th channel, which usually maps to 3, and we're going to use SS and TT. And we close our mix. But what if the texture doesn't have the 4 channels? Well, in that case, we're going to do else. We're going to do here SC equals LC. Basically, we're going to do an override because there's no channel, so there's no alpha. So we're going to go ahead and override. And then the last thing we have to cover is what happens if the user decides not to use the alpha. Well, we can skip this lookup over here and just immediately do the assignment or the override of surface colors equals layer color. So that being done, let's go ahead and see if this compiles. It compiled. So now let's go over to Maya. Let's reload the shader. We have our new parameter, and if I click render now we have our decal, And you can see that because I changed, the color back here is a magenta. If I change this to an orange and I click re-render, it's going to update. So there you have it, a very simple introduction on how texturing is done in RenderMan. We're going to have a couple of other videos that is going to show different techniques that you can apply. But this is pretty much what you're going to need to do. You're going to need to do a texture lookup with your SD coordinates, and a lot of times it's a good idea to at least have controls for this flip S and flip T. And then usually you want to do this lookup in case the user has provided an alpha mask, which is very common, and you want to support that. We have used this color only to be multiplied against the diffuse lookup, so we're using Lambert shader right now. And in other videos, we're going to show you how you can use the red values to change a specularity or some other components. So that's it for now, and we're going to move on to another video. Thank you very much.